All right, geometry. We just finished chapter 1. We're starting up chapter 2 now. 2.1, inductive reasoning. This chapter kind of talks a lot about logic and things like that. So sometimes there's a little less calculation here and there. But this first part is called inductive reasoning. So inductive reasoning is making a conclusion based on observations and patterns or patterns. Okay, so you see a pattern happening, so you can kind of make a conclusion. What's the pattern going to lead us to? Okay, and so a conjecture is that conclusion. It's another name for that conclusion. So a conjecture is a conclusion reached using inductive reasoning. Okay, there's a reason I don't write in lowercase letters usually. So let's look at some examples. So look at the pattern, see if you can figure out what the next thing is. So the pattern here, 38, 31, 24, 17. So just looking at random numbers isn't going to help. So figure out how are they getting from one number to the next based on this. So if you look from 38 to 31, 31 to 24, 24 to 17, it's going down. And how much is it going down? Each time it's going down 7. So really, you're just subtracting 7 each time. So we're just going to think of the next 3. So that'd be 10, 3, and 3 minus 7 is -4. Okay? So your conjecture is they subtract 7 from the previous term. Okay? Subtract 7 from the previous term, or from that number, to get the next one. Okay, so look at this one. It says 4, 10, 18, 28. So this is going up by 6. This is going up by 8. This is going up by 10. So it's going up by a certain amount each time. So this is going up 6, up 8, up 10. So this is probably going to go up 12, which is 40. That's going to go up 12, 14. So 14 would be 54. 14, 16. So that would be 70, and so on. Okay? So the conjecture here is that we're kind of adding two more than the previous amount added. Okay. Now you could probably say that more elegantly, but adding 2 more than the previous amount added, not adding. Okay, so it's going to go plus 6, plus 8, plus 10, and so on. Okay. So the next one, we have 10, 4, -2, -6. So this is going down again. This time it's going down by 6 each time. So subtract 6 from previous term. Okay, so subtract 6, that'd be negative 14. Subtract 6, that's negative 20, negative 26, and so on. Okay, so some of them are not necessarily just numbers, though. So like this one says, the sum of two odd numbers. So if you want, you can kind of think about some examples. So like two odd numbers might be 3 plus, or 1 plus 3, which is 4. How about 5 plus 7? That's going to be 12. How about 7 plus 11? That's going to be 18. So what do you notice about all three of those numbers? We added two odd numbers together, and every time we got an even. Okay, so we could say adding, or let's just say sum of two odds gives an even number. Okay. So the last two, we have 730, 755, 820. It's going up by what? 25 minutes each time. So adding 25 minutes to the previous time. So in this case, it would be 8:45. 45 plus 25 would be 9:10. Then the next one would be 9:35, and so on. Okay. And then the last one here says an even number multiplied by any other whole number. Okay, so try it. So 2 times anything, 3, equals 6. Okay, 4 times 7, that's 28. And then how about 6 times 2, that's going to be 12. 8 times, I don't know, 4, it's 32. So look at your result each time. Again, the result is always going to be even. So an even number.
Staff, if you've not seen Evan Cooper's email, please take a look-see at that. That's pretty much pertaining to anybody that's parking on the south lot.
Sorry for the interruption here. An even number multiplied
if you would at this time,
by
please move your car
any
as those kids will start
number
moving back to that area relatively soon.
by any number gives us an even number. Alright. So an even number multiplied by any number gives us an even number. Any whole number, so not decimals. Okay, so the last thing here, counterexamples. A counterexample is something that's going to prove it false. So if there's a statement said that you know is not true, you provide a counterexample to tell why it's not true. So an example that shows a conjecture is false. Okay, so we're not going to go through every single one of these, but there are some important ones. We're going to go through, let's go through the evens and 5. The evens plus 5. So look at the first one. Number 2, we have the product of two numbers is always larger than either number. Okay, the product of two numbers is always larger than the number before. So first of all, think about that if it's true. Any two numbers, if you add them together, is going to be larger than either. Well, What about the number 0, or what about negative numbers? Okay, so in this case I could say false, and my counterexample would be something like 0 plus 2 equals 2, okay? Because 2 is not larger than that number. That would be one example. Or you could say something like negative 5 plus 3 is negative 2, and negative 2 is obviously not bigger than negative 5. Or the other one, 2. Okay, so number 4, if the area of a rectangle is 6 meters squared, then the dimensions must be 2 by 3 meters. That's not true. That's false. Can you think of the counterexample? So 6, how else could I have 6 meters squared? Well, 2 times 3 is 6, but what else? 6 meters by 1 meter would also give me 6. So it could be longer in one direction, okay? So what about number 5? If n is a real number, then n squared is greater than n. Okay, so you have something like 2 squared is greater than 2. That's true. Okay, negative 5 squared is greater than negative 5. That's true. But what about like a fraction? We could have something like 1/2 squared. That's not greater than 1/2. Okay, so that would be a counterexample. False, because you could have a number like n equals 1/2, because if we work this out, 1/2 squared is 1/4. 1/4 is not greater than 1/2, and that would be our counterexample. Okay, so number 6, vertical angles are never complementary. Is that true? Well, if you remember, vertical angles are the opposites, like this, angle 1 and angle 2. Now, to be complementary, they have to add up to 90. Well, couldn't I have 2 angles that equal 45 degrees here and 45 degrees here? Okay, so that would be a counter example to this. False, again, because 2 45-degree vertical angles are also complementary. Okay, so last couple here, and then we'll be about done. So 2 angles supplementary to the same angle must be congruent. 2 angles supplementary to the same angle must be congruent. Well, let's say one angle, let's say this is 30 degrees, and this angle is supplementary to that angle, and that's 150. 150 plus 130. Well, if this angle is also supplementary to that angle, doesn't it have to be the same as that? So if this is supplementary to this, then it has to be congruent. Okay, so there's no way to prove that wrong that I can think of. Okay, so number 10, if JK equals KL, then K is the midpoint of JL. Well, that situation could be true. So JK is congruent to KL, then K is the midpoint. That makes sense. But does it say anything about JL being a line? JL isn't necessarily a line, because what if the situation looked like this? JK is congruent to KL. Then K is not the midpoint of that, because That's not one segment. Okay? So this would be your counterexample. Okay? And the counterexample could be a picture. Doesn't have to be words. Okay? So like this was a picture. All the other ones were words. Okay? So that last part here, we're going to talk about that doing a flip grid. So we'll talk about that in class for the Monday people, and the Tuesday people, I'll talk to you in class about that as well. All right? So get on with what you're doing, and I will be ready for questions if you email me. Peace.